Okay, my name's Robert Witt. What I do here is I'm the quality control manager. So every piece of equipment goes through my department. We wash, wet test every piece of pumping equipment we build. This is the Gantry class, and we're going to start by talking about how you hook up the wires to the gantry itself. If any of y'all had the pumping plant class yesterday, there may be a little bit of crossover where we kind of cover the same things, but there's a lot of things that are similar in these two classes. Let's go ahead and get up, and we're going to be standing up probably the first 20-30 minutes and get over here to the main panel on the gantry. Okay, basically you have three different voltages that you're going to be hooking up to this panel. The motors and the variable speed drives here is going to be 208 to 240 volt three-phase, and you're going to put those and connect these to the bottom of the disconnect switch there. You also have 24 volt AC, which you're going to supply to the common terminals on that output card, and that operates all of your solenoid valves on the gantry itself. You also have 24 volts DC. Now, when you hook that up, when you're doing an install, you do not hook the power directly to the terminal strip. You have a DC filter up here. There's going to be a pigtail down in the bottom, and you make your connection there. And what it does, we are laying the DC and the COM cable right next to, in the boom, the three-phase AC. We put a filter in there, and that'll kind of clean up the power as it comes in here. In the same cable with the DC is also your communication, and you just make that connection right here on 14 and 15 on that terminal strip.
Out of that, you supply power to your terminal strip, though,
No,
right?
yeah, whenever you do the connection, you're just going to hook it up to either 1 or 2 is your hots, 3 or 4 is your neutral. So that's the only connection that you make with AC is right there.
I thought that was...
No.
So DC is the one's filtered, right?
DC is filtered, yes. All of these electronic components in here, the input and output cards, your eyes, your proxies, which I'll talk about a little bit later, all of that operates on DC, 24 volts DC. All your solenoids and the motor starters in here operate on the AC. Except for the big motor starter for the 25 horse, you put that in with 110 volts. Any questions about anything in this panel? These drives here, they're variable frequency drives. By changing the frequency, which is what you see displayed right here, we can control the speed of the motor. We actually run the drive motors, which is the one in this position at 55 hertz. At 2 different speeds. We have a regular speed, which is 55, and we also can slow it down to 30 hertz. So we cut the speed almost in half.
The error message drive motor ran too long. Does that have anything to do with
No.
the speed of that?
No. When you get an error message that one has run too long, generally it's a prox problem. It's looking for, when it's in automatic mode, it is looking for the unit to be sitting at home and the boom to be all the way up. If it doesn't get one of those proxies, then you're going to get a motor run too long, either a boom or a drive motor. You have 2 drive motors, one on each side. We operate both motors out of the bottom of the same drive. If you start getting like an overcurrent, where you're tripping the drive out, you can isolate one motor. Just remove 3 wires, 1 from each terminal. Now you've only got 1 on the bottom. You can punch the button and see if it's still tripping. If it is, then you know the problem probably lies with the one that's still hooked up.
Are those wires identified up there? Or you have to take a harness loose, see which one's going where?
Well, yeah. What we have is the one that goes to the left motor. You can see the 3 wires go into this conduit. The one that goes to the right motor comes over to this side. We have 3 oscillating motors. We run those at 35 hertz. So you have 3 sets of wires that come into the bottom of this, and that's the same thing. And you would just isolate, if you're getting a trip, isolate one motor at a time until you find which one is the problem. We have a single boom motor that's situated off of the center. We run that at 60 cycles. We We used to run that at 45, and we had a 30-to-1 gearbox with a brake on it. We had some problems with the brake, so we ended up going to a bigger ratio, which allows us to no longer need the brake. We run it 50-to-1. We have also changed from 1/3 to 1/2 horsepower motors all the way around the unit. Now let's step off to the side here. This is the oscillating motor. Those of you that may have some older units out there, you may notice that we have changed the way this mounts. We used to hang it vertically. The motor's really designed to sit horizontally. Since we have done this, it has increased the life of the motor. Also helps on not getting as much water into it, because that's the death of these motors. You know, it's in such a wet environment. You have the bearings that these sit on are just called pillow block bearings. They have a grease cert on them. We recommend that you use a marine grade grease to lubricate them. You've got 4 of the 1 1/8 on each side here, and then you've got 6 across the top of the 1 inch for the boom drive shaft. Now the adjustment on this. Now usually if you just need to change one, you know, just break the jam nut loose after you take it off, unscrew it, screw the other one to the jam nut, and you're done. But sometimes you may have to take it completely apart. What you want is, should the car be all the way against that aluminum guide rail, you want these things to still have a decent amount of overlap. If you don't adjust them properly, then you'll just leave a stripe down the length of the vehicle. What I generally do is I want the spray on the high pressure to almost hit on the bottom of the top opening and on the top of the bottom opening to give you the greatest amount of overlap. Those of you that got the toolkit, this is the meter that is in the toolkit. It's a real nice little meter. It's got a lot of features of much more expensive meters. One thing I like is you have the non-contact voltage, so it's a hot stick, you know, just to see if the panel's dead or not. I really like that feature.
Yeah.
I like even something as simple as this being able to clip onto here.
Explain on Tommy how to use that real quick.
Oh, give me a break.
That just always leaves your one hand free. Now on here, if you want to see how much while it's running, you can hit this mode button right here. While it's running, it's gonna tell you how many amps it's actually pulling. Both of those motors are actually putting on this. Another feature that this has, and we're gonna go through and program these. When it's on H right there, it will actually show you the frequency that the drive is putting out at the time. So there could be a problem with the drive. You can see the unit's running slow. You put it on that, and you might see it, for whatever reason, it's not getting to 55 cycles. It's only getting to 45, therefore it's running slow. So those are nice features on this drive here. Because a loose connection can cause the amperage to go up on anything.
Yeah.
Again, you're probably not going to have that problem on the Gantry, because the whole Gantry, while when it's running with everything on it, not including the blowers, is only pulling 7 or 8 amps with everything running. So very low amp draw on this. Now the 25 horse is pulling a lot of amps, and as are the blowers. This is a meg ohm meter, and what this will do is it tests the windings or the wiring in a motor, and you're looking for leakage to ground. So whenever you're hooking this up, you have the black one on ground and put the red one on on a leg. You can actually meg from here. Let's say you have you're suspecting that you have a bad motor. You can actually disconnect from right here and meg the motor from right here, and you're also at that point also checking the insulation on the wiring going to the motor. This tool right here is very valuable to have, because it can save you a lot of time of troubleshooting. Maybe it's an intermittent problem, which you'll see sometimes having electric motors in this environment. You may get a little bit of water in there and it starts acting a little bit screwy. This thing right here will save an awful lot of time. Let's let me just bring the motor over here since we're all standing here. Yeah, this puts, I don't know, 500-600 volts through there. Really no amperage, but okay, you always put one to ground, then you test it. And this one shows to be okay, and you can test the other 2 wires.
So what is the reading on that?
It goes all the way down.
Okay.
And then if it's above 1,000, then you won't get any light. You'll just see the green light on. Whenever you get a bad motor or a bad winding, then the red light will come on. You need to start worrying about it. If you see it creeping into the yellow, you're going to have a problem soon, so you need to think about changing that. Now, you may not, have to get it overnight shipped to you or anything, but it'll work for a while. But
Now, how can that tell a motor's going bad?
all you're doing is testing for leakage to ground. You're sending so much voltage through there, just insulation broken down in a wire will leak to ground with that much voltage.
So that's not necessarily, so if you put that on a pump, it's not going to tell you whether that pump's good or bad, it's just going to tell you if there's a leak in the wire.
Right. Just because this says good does not necessarily mean that the motor is good. It just means that it doesn't have, the windings are not leaking to ground. I mean, there could be an open in the wire. The motor would not run. It's bad, yet this won't find it unless that thing is touching ground somewhere.
What do you mean by the windings? The windings inside the motor?
Inside the motor. Inside the motor.
It's actually the current's actually getting into the motor and then sending back a signal to that.
It goes whenever it's basically, it's just checking for, this is called a mag ohm meter, so it's lots of resistance. It will actually go across gaps if you start getting, just poor insulation on the wires, on the windings in there. It's actually gonna put voltage to ground, and this will pick that up.
So when you're doing it, you're not just checking to make sure that the wire you're hooked to doesn't have a cut along the lines.
This will not find that.
That will not find that if your wire is nicked, going up to steel or anywhere.
Right.
You know what I mean?
It'll find that if you're on ground.
It will find that.
But usually when a motor breaks down, that's what happens. The windings from the heat and everything start breaking down, and then it just sends that voltage to ground. Now, when you're up in the yellow, that's already begun to happen.
Okay.
But like I said, you're going to need to think about changing that motor soon.
Didn't quite understand it.
Can you isolate the wiring if you get a red reading? Can you go to the motor itself?
Yeah, absolutely.
Check the motor, and if it's okay there, your wiring's the problem.
That's correct. Now you can use this to test the comm cable. I've got one right here. Now anytime, the only component you can hook this to is a motor. Don't ever hook directly to the bottom of this drive, because as soon as you push that button, you just bought a drive. Right. Comm cable, extremely important. If you were to disconnect it at one end and leave it connected at the other, you would fry every component wherever it's hooked up, whether it be at this end or that end. It'll zap every 24-volt component in there. Now to test the comm cable,
Without it being hooked up.
yeah, must not be hooked up. And you can go to ground. Now on these, you can go from wire to wire. You're not actually testing a motor, so there may not be any leakage between this wire and any of these. It may only be between these here. But you just go to every combination and check for a short there is basically what you're doing. You could do the same thing with the ohm meter on there. You're not really looking for, the big ohms that this is, but this is a quick and easy way to do it. You just go punch the button, punch the button, punch the button. Okay, now this here is where it plugs onto the bottom of that cabinet. When you hardwire it, the way he does a lot of times, it makes it a little tougher to troubleshoot a DC short, because then you have to actually unwire it. If you get a DC short anywhere in this system, it will shut down the DC power supply. So when you walk up to the unit, you'll see no power, no comm, everything's dead. But yet you start checking voltage and you have voltage everywhere. You've got 110 to the bottom of the power supply, you've got your 3-phase, you got all this, but nothing's on. So at that point, the first thing I do is unplug this, isolate the gantry from the pump stand on the DC circuit, and boom, it comes back on, and you know the short is out here in the gantry. So it's a quick and easy way to be able to do that. Because you have all of your proxies and eyes, anything, you know, a bad component could cause it, or you know, a break in the wire where it's touching ground can cause it. It cause a short as well.
Now, all proxies and eyes run off the DC voltage, right?
All, yes,
All of them.
all the proxies and eyes.
And then all motors run off the AC voltage.
That's correct. And the solenoids all run off the 24 AC.
AC.
Right.
Even the big 1.5 inch on the side,
1.5 inch.
1 inch on the side for the rocker panel.
Yes, still 24. Everything on this gantry, all the solenoids run on 24 volts. And like I said, everything with the exception of this in here as well, or on the pump stand, runs on 24. The big one is pulled in with 110 volts.